Alright, so we're back here. So from the previous video, I was toying around with getting render code working. I finally got it working so that way I could put an object on a creeper's head and it should rotate properly. I figured out the methodology for this. You want to first rotate to the center of axis you're going to rotate on, which is what I thought I was supposed to do in the first place, and I was correct on this. It's just I was going about it the wrong way, and it finally got it there. So you rotate, you put the point of rotation on there. So for this, it's going to be the bottom corner of the block. As I was noting, that was the bottom left-hand corner. So you put that on the rotation point, which is the neck, like I said it was going to be. You then rotate that. Then you translate back to where you actually want it to be. So in this case, we want to move that bottom left-hand corner back to the other spot of this. So now we get a block that rotates perfectly with the entity's head, and it works beautifully. The next step for this is to now get the block to move where I want it to move to in order to get to render. Additional thing I also did is I'm now translating by the scale factor. This is helping a lot. I think I need to times this by the scale factor too, so this actually might be 2 point something. But 1 point seems to be working, which makes somewhat sense because this entity is only 2 blocks tall, so translating up 2 would be too much, but 1.13 is the actual height of that next one as far as I understand. But it's kind of confusing that this would work. Actually, no, it does make sense, because what you're doing is you're translating, then rotating, and it just happens to be that this translation one needs to be translated by the scale factor, because then you're changing the size of the object, but this is just moving your rotation point, which, that's the theory. That's what I've got in mind. I still got to do some work to figure out if that's actually what's going on, because OpenGL code is not the most intuitive thing in the world. But the next step we're going to do is we're going to get this thing to rotate. So I'm going to go ahead and do this on camera and hopefully not completely botch it, because, well, I was toying with this earlier, and give or take if it's going to work. So how this rotation code should in theory work is that should rotate in an orbit around a fixed point. So what you're doing with this code here is you're going, okay, I know where my center point of rotation is, and now I want to move my position around that center point of rotation to a different point. Now this code right here is going to give me a vector that's always going to be from 0 to 1. So my values here are always going to be 0. Well, actually, I think it'll be negative 1 to 1. Maybe. It'll be a thing. So you'll get a value out of this, and what you can do with this value is you can multiply it to get your rotation point, or get your distance from your rotation point. Now, in theory, my rotation point is going to be what this is. So it should work, because what we're going to do is we're going to translate our render position by the rotation. And you can see this is kind of producing a result. It's not producing a consistent result because, of course, we still got some work to do. But it is producing something. It's just that something is going to result in some weird behavior. Now, technically, I don't think I actually need this pitch value, because we're not orbiting on a pitch. We're just doing yaw here, is what I need. So let's do this. Let's see if we can get this render position to orbit some kind of fixed position on the Y. And it looks like it's working. If I can get the entity to actually aim at me. It's working. So I'm now getting that to rotate on a fixed point. Given I think you can do this without doing the rotation. Yeah, you know what? I can do this without the rotation map, I think. I think I also got these flipped. Let's try this. Let's see if this might work a little better. Follow me? Follow my head? What? So the one time you want this to follow you and it's not actually working. So we are getting a result. Is it consistent though? So it is orbiting a fixed point. It's just that's going to result not what we want to do. So I don't think it's the correct methodology. Now, if I wanted to render something from a fixed point around the object, this actually would kind of work. But it's not going to work in this case because what I really actually need to do is I need to toy with this translation value. So we know this is going to move us towards the center. Now we just need to decide, okay, where is our object going to be? So we're going to get rid of this stuff. I'm going to comment it out because I'm going to leave it there. And that still might be useful code because it's producing results that are interesting behavior-wise. The next thing to do is just move this. So this is our X, this is our Z. So we do want the block to come out. And what I also want to do is I want to make this block a lot smaller, so just for testing. Let's see if our code can actually adapt to this. I think our code actually is adapting to that. So this is definitely something I should write some much nicer algorithms for to actually make it work properly. But we should be able to make it come out of the Z by doing basically what we're doing already. So let's say we want to move it by another 0.5, and we times it by the item render scale again. And the entity walked away. Might have to times it by a lot more to get that to come out of the front of the face. This is where I'm unsure if our render code is adapting properly, because I should see this object somewhere, and I'm not actually seeing it. I'm just going to start doing +2 here, just because I need to figure out where that object actually is that rendering it. Okay, there we go. So we get that right there, so this needs to be a -2 value. We'll do -1. So that's going to be in front of us, and this should update in theory. Come on, face me. Okay, so it was following the rotation. That's good. So we know this will work then. So what we want to do is we want that to be on the top corner there. So I don't need to be moving as far. I think I still need to be doing the scale factor here. And the reason why we're not just changing this value right here, and rather we're doing a separate value, is just to kind of keep it consistent, because what will happen is if... Actually, the way I really should be doing this is I should be just running a second GL translate call. That way we keep it clean and consistent, and we know what translate call does what. So this one is move object to center, and then this one would be move object to render position. That way we know what the code does and I don't misspell things. Documentation is important so you know what you're actually doing. So that's actually not moving the render thing, so I don't think the scale factor is doing what I needed to do. In theory, I shouldn't have to move the whole entire block. Yeah, so we're not getting the result from the scale factor that I need to do. So we just times it by that and it'll work. I think it's a negative value. Yeah, it's a negative value. That's why we might not be getting results. I might have been pushing out the wrong side of the head again. We just went through this a couple seconds ago. So let's put that scale factor back there and put a negative in front of it. That way I actually just check to make sure if it was my mistake or if it actually was a problem with the scale. Still not getting movement. Try one again. This is going to produce a value which is really small. And I think, yeah, we actually are just going to have to do something like that. I'll have to figure out later how to get that scale factor to work properly. And there we go, so that's pushed out to the front there. And it looks like we can probably get away with 0.5. And the actor moved away. Okay. So you can get much smaller result. I'm going to try like 0.2. Okay, so that gets basically what I wanted to do. And then I'm going to say we're going to get about the same result here. Wrong side of the head, but I mean, at least got the distance right. So it looks like it's about half the width. Because this face width is about 8 is what it is. So I guess it's on the corner there. And then we just, for the Y, we just need to move up, I'm going to say 0.4 will get us the result we want. You can do really cool things with this as well. You can actually put blocks on faces with this code. You put tons of blocks. So say, for example, there was a mod author I was suggesting to add crystals growing out of sheep, because he has a sheep mod that does ore blocks. So you have ore blocks that grow and you can shear them, just like you do wool, instead you get ore back. I was like, hey, put some crystals on those, and those look really cool. This is actually probably one of the ways you go about it. The easier way would actually be to make a model with the crystals on it, and then just make the crystals render. It's far simpler, but if you wanted some dynamic code that did things, this is how you go about it. You would do some basic calls, basic translate. This code as it sits is functional. I could work with this. The main reason I probably will keep working on this is I would like to be able to have code where I can come up here and go, okay, I want this block to render twice the size, and if I get it twice the size, unfortunately the render position is going to, actually does not break. This is the weird thing about OpenGL, which I don't understand, is that you figure out some kind of rule set that you go, okay, here's the rules how OpenGL works, and then it doesn't work that way. So we're translating effectively by 0.2, when this face is definitely not 0.2 in size. So if we assume the render size is 1, from 0 to 1 on this factor, even if our render position was 0, 0 here, that still should be 0.5 all the way to the edge, but we're doing 0.2, and this face, 4 pixels, if it was so 8 would be a full 0.5, so 0.25? You know, I wonder if 0.25 would make us get a little closer to the... if the factor would stay still long enough. You know what, I think it actually is 0.25. This means this would be 0.5. So this makes more sense. It's just still confusing. This is why I don't like render code. It looks like from the X and the Z axis, it works, but from the Y it doesn't. The Y actually does kind of make sense because I don't think the relative position is the same. Because this would be 4. This would be 8 all the way up to the top. Which then would be, but should in theory be 0.5. We're also noticing, if we actually look at this, when the head actually starts to pitch up, it actually is not moving perfectly. Come on, look up a little bit here. I don't want to force your head rotation just so you look up. Some motivation here. There we go. So it looks like the position is moving just a little bit. It's not as noticeable, especially when we put a 2D item on here. It's actually going to be probably a lot less noticeable, but you can see it kind of flicker there. This is one of the reasons why I didn't want to use the model head position for this, which I may go back to. But actually, no, I know exactly how to fix this. I needed to interpolate between the previous yacht and the yacht, and it would fix it, because what I'm seeing is exactly the reason why you interpolate or use lerp functions, is because you get a snap, and we're seeing a snap of movement instead of a really smooth flow. Because one thing to keep in mind when doing rendering, you are re-rendering everything every single frame. So if you have 60 frames a second, you're rendering it 60 times a second. And unfortunately, your game logic is only running at 20 ticks a second. So you will render 3 times for every 1 time you actually do logic. So if your logic between 2 states goes from like 1 rotation, 2 rotations, you'd get a snap, because then you went 6 frames before the next logic update went through and made your rotation, so you would actually see that snap, because it's 6 frames is quick enough for the eye to see. And if you lerp it over that time instead and use your delta time, so there's actually a delta timestamp of that goes, okay, how much time relative to our logic passed between frames. And then you can use that to use your interpolation function, so that way you guaranteedly go, okay, I know this logic is going to take 6 frames to render, and I need to make sure that when we're going between, say, 3 to 6 rotation, that we spread that out over multiple frames to actually make it look nice and smooth. Anyways, I'll leave you guys here, and I'll be back with more stuff. Not sure when, but eventually. Hopefully I get the last part of this, which is the bow tie rendering. And for those who actually are asking why in the world I am doing this, Direwolf20 posted a picture asking for somebody to make this, and I just went, sure, I'm going to go ahead and make it. It's kind of cool, and it's a reason to make a new mod. I've been wanting to make a creeper mod for quite a while. I used to make a couple of them in the past. I had one for ICBM, where you had all the ICBM explosives creepers. So they're all going to come back, along with a ton of other ideals that I have in the waiting list. Things like having the creeper body be replaced by a missile, technology-based creepers, things with like you have a furnace in the chest of a creeper that actually cooks items, so when you kill the creeper it drops cooked items, and so on and so on. But I'll get back to that with the design document, etc., in more videos later.